Continuing.
You just always color worksheets.
All right, remember the mean value theorem? Mean value theorem
I think he does. I don't really know.
for
I'm just gonna guess.
definite intervals. Quick reminder, mean value theorem said this. If I have a function, at some interval from a to b, the mean value theorem said, let's suppose I wanted to find the tangent line at some point c. Alright, so the tangent line would look something like this. The mean value theorem said that at some point, or there are 2 points that exist somewhere, that I can draw a secant line that is parallel to the tangent line. There's some average kind of y values, x values here that will give me the same, they'll give me a line that is parallel to the tangent line, a secant line that's parallel to the tangent line. Okay, so that was the mean value theorem. We said, hey, I think we spent like a day on it. That was the mean value theorem. Now, it said, it was an existence theorem, right? It said, hey, this line exists. It doesn't tell you anything about it, or any other information, but it says that that line exists. Remember we used the example if you're on the Ohio Turnpike or something like that, and they take your average speed, they can figure out from your average that at some point you broke the speed limit, right? That was the mean value theorem in 1 minute. It was really exciting. Now, let me give you the one for integrals. It says this. If f is continuous on AB, then at some point C in AB, so somewhere in between A and B, this is true. F of C equals 1 over B minus A times the integral from A to B of f of x. That's the math jargon. Okay. I've got a couple pictures here that I think will help give you an idea of what this theorem means. But it says if f is continuous, we've got to have that. And there's some point C and AB where I can find a function. And this gives me the, well, we'll look at that picture here. I won't give too much away. All right. So, suppose we had a function. Something to this. Okay. Suppose it's continuous from A to B. Whoa. And suppose this is y equals f of x, so this is my function. The integral from A to B of f of x dx gives me this area underneath the curve, right? So we wanted to find this area. That would be given by area under the curve equals integral from A to B of f of x dx. Okay. Nothing hopefully new there. Mean value theorem says this. If I take that same function from A to B, it says that there is some point C that the area, do I want red? of this red rectangle, the area of the red rectangle is the same as the area underneath the curve. Okay? So we would say that this line right here is f of c. Okay, this in black is y equals f of x. Okay, so it's the same function. This line is given by f of c. Not necessarily. Good question. Like I said, is c the midpoint between a and b? That's not necessarily true. All right. So we would say, what is the area of the red rectangle now then? What is this area? Remember, this top line is given by f of c. Just a rectangle, length times width, right? What is this length? B minus a. Okay, so this is b minus a times what?
F of c.
F of c, right? Whatever the height of the rectangle is, which is f of c. Okay. So we know that this f of c must exist, okay, by the mean value theorem. Right? For integrals, it means that the area here in red must equal the area of the integral. So hopefully you can kind of see here that I've got a equals this thing, a equals this thing. Okay, so I think we could set the things equal to each other. Right? So we'll say this. I'm going to go orange here. All right, we'll say this. The integral from a to b of f of x dx equals b minus a times f of c. You okay there? Agree with me? So really we're proving this is what we're doing. We know that this c exists by the mean value theorem, okay, so we're just proving the theorem here. All right? How can I make this look like my theorem? What kind of algebraic manipulation could I do here?
Yes, the reciprocal.
Yeah, I mean, you could say that. The reciprocal of b minus a are the same as multiplying by 1 over b minus a, right? So, or you might even think of it like this: divide both sides by b minus a. Isn't dividing by b minus a the same as multiplying by 1 over b minus a?
Yeah.
Okay, so sorry I ran out of vertical space here. But so we could say this, that 1 over, 1 over b minus a, okay, right, divide by b minus a, times the integral from a to b of f of x dx equals f of c. So that's the proof for the mean value theorem for definite intervals. Well, proof's maybe strong work. What kind of a proof? All right. Any questions on what the mean value theorem for integrals kind of means or says? One way to think about it is, imagine if this was like a glass, and it was full of ice that was kind of oddly shaped. At some point, that water will melt and it will be perfectly horizontal, right? It'll fill the glass. That's kind of what this point represents, or this line represents, is the top round. If that helps or not. All right, let's do an example. Can I erase at least this part? Okay. And I think you'll see that the examples are pretty much just plugging stuff into the equation. All right, suppose we wanted this. You're going to get to use your calculator for this one. Example. Okay, find the average value of the function f of x equals 4 minus x squared. What are your race symbols? x squared on the interval from 0 to 3. So what this is really asking for, it is asking for f of c. It's basically saying, hey, find f of c, the average value of the function. What is the average value of the function? So find f of c. Well, I know what my function is, and I know my interval. So if I look at the parts of the mean value theorem for a definite interval, I need to know my limits of integration, or my interval, a to b. I also need to know what my function is. I think that gives me everything that I need. Okay, so f of c equals 1 over b minus a. Well, what is b minus a?
3.
3 minus 0, right? Yeah, this is my a. This is my okay. Times the integral from 0 to 3 of f of x. Well, f of x was 4 minus x squared. Yeah. Okay. Now this is where you're going to have to use n int if you haven't technically figured out how to find this area yet. Someone use n int to figure out the area underneath this curve from 0 to 3. 4 minus x squared.
3.
Oh, I get this one. 1 over 3 minus 0 is 1 over 3. Remember, kids, my joke's lacking quality. Make up for one. Alright, can we figure this out yet? It's 3? Oh, convenient. Alright, so 1/3 times 3 is 1. Alright, so the average value of the function is 1. What does that mean graphically? I don't know. Show us. Alright, let's see. 1, 2, 3, 4. I think this is, let's see, an upside down parabola. Parabola, what? I don't know, I've only seen that word written.
You've never said it.
Wait, are you
okay, I was like,
You should not be teaching people. You don't know how to pronounce it.
In fact, you know what? I just
What is he doing?
Okay. So this means that at 1, f of c equals 1. So that's the average value. The integrals from a to b, well, b is at what? 3. So we're looking at the integral in 3 colors here of this area down to 3, which is this guy. So that's the integral over which we're looking for. The average value of the function is at 1. And that's it. Like I said, the examples are pretty much.
Why wouldn't you call it this side?
Any questions on the mean value theorem or rules for definite intervals? That's all I got. I must have been in a Christmas mood when